So in the first video, we described the task and we created the project in TIA Portal. And we sort of did a lot of our configuration and setup. Now what we want to do is we want to start to code this. Okay, so I'll bring back up the tasks that we're looking at. And remember, we're just going to look at these first four for the moment. So I've got A plus B plus A minus B minus. And I can see what step number they're going to activate in. And remember, I go up in groups of 10. And I have an output for each movement. So that makes it a lot easier. So what I like to do is I like to code my outputs first. So we will go ahead and code it. So what I'm just going to do is I'm just going to pop in my outputs here, A extend, then sorry, we wanted to do B extend, and then A retract, and B retract. And what I can nicely do is, well, I can use some comparators here to say when I'm in a particular step number. So I can find them over here, comparators. The ones I'm going to be using, I'm going to take them equal equals and the not equal to. I'll also need them, well, I'll come back to the move. So what we're going to say is when the value in our data block and in that position cell, when that is equal to 10, we're going to go ahead and make A extend. Okay. Then what I can do is I can copy that down. And when it's equal to 20, we'll make B extend. When it's equal to 30, which would be the third step, I can make A retract. And I can copy that down again. When it's equal to 40, I can make B return. So that's my control of the outputs. That's as simple as it is. Step 10, A extends. Step 20, B extends. Step 30, A retracts. And you can look at that directly. Step 30, A retracts. Step 40, B retracts. So outputs get driven directly by the step numbers. We're not doing a direct input to output correlation here. We're using these step numbers as a kind of middleman. So we're telling our system how we're going to be activated. And then what we can do for our inputs is we can basically say how we're going to move through the system. So our outputs get activated by step numbers and our inputs change or move our step numbers. Okay, so we're going to need that move button. I can drag that up here. I can bring that down there. So what you get, if you know you have 4 steps, what you can actually do is you can keep this sort of a structure here and you can copy it down and just increase your steps as you go. In step 20, move to step 30, and in step 30, move to step 40, and the final one in step 40. We'll leave that blank for a moment. So you can see here, I know I've got four steps I've got a code for, so I've created enough for 4 steps. So in step 0, what do we need to happen to move us into step 10, which is step 1? When we're in step 10, what do we need to happen to move us into step 2 or 20? Step 20 into step 30, 30 into 40, and then 40, and we haven't just finished it off yet. So step 0 is always rest, okay? So nothing is on, system hasn't started yet, and we're basically saying, well, how do we know we want to start? We press the start button and we move into step 10. So what that is saying, if I'm in step 0, wait till I hit the start button, move into step 10. And we could, make that a bit more rigid if we wanted to say, you can put in the key switch, pop that in there. That means then the system won't start unless I push the start button and I turn the key switch. And even if you wanted to, you could add a bit more into that to say, well, I want to check that my cylinders are retracted. So I can use the sensors there to check those. So now once all those conditions are satisfied, I'll move into step 1. So in step 1, we're waiting to know how do we know when we're finished step 1, then to move to step 20. Well, in step 1, A extends. How do I know when A is fully extended? I can use my input AL1, which tells me A is fully extended. So then I can go to step 20, which means it's no longer in step 10, so that output will go off, and in step 20, B will extend. So I can copy this down, except I'm using BL1. And then we know A has to come back, so that would be AL0. And then finally, in step 40, B has to come back, which would be BL0. Because I know in step 40, B should be coming back. So that should be BL0. Now the final thing to do is, well, what do I move to next? Well, if I move to step 50, I'm just going to be stuck in step 50. No outputs are going to happen and nothing will continue any further. So really I want this system to be repeatable. So what I want to do is I want to move back to step 0, which will bring me back up to here. All the outputs will be off because nowhere does it say equal to 0 do something. But then we're up here and I'll wait for the start button to be pressed and the key to be turned, and they should be back in position and we can start it again. If I moved to step 10, it would automatically start the sequence again because it's bypassing the start, and the system would just stick in a loop forever. It would be autonomous. But we're going to go ahead and move back to the start, so we have to press the start button to start it again. Only other thing we want to think about in here is, well, what if we want to stop the button or stop the system at some stage? We might want to use a reset PB, and we would put this line of code in. If we press the reset button, it'll move us to step 0. Because we know step 0 turns off all our outputs, because nowhere here do we have equal to 0 do something with an output. And we know in step 0 we'll wait for someone to press the start button again and even bring back the cylinders before it'll start again. One thing to note is when we have a reset button, we don't put anything before it. We don't put a number before it, because that means in any step number, this can be active. If we did do something like this here, that means this reset button would only work in step 40, which is not what we want. We want to be able to stop the system or reset the system at any moment in time. So for that system, that fairly basic system, that would be how it's completed.